Dear colleagues, we are on air at the moment, and we're just gonna give a few moments for all the other participants to join us. Well, hello once again, dear ladies and gentlemen. Thank you very much for joining our webinar today. My name is Katrina, and well, this webinar is a preview of important discussions that will take place at our Yamal Oil and Gas Forum in Salihard on the 8th and 9th of June this year. This is going to be our 5th annual event, and definitely you're all very welcome to join us. So today during the webinar we will get an insight into the development of Yamal oil and gas investment projects, and we'll provide you with a set of tools for acquiring competitive benefits in the current market conditions. I will probably present a brief overview of the Yamal projects, and I will continue with their presentations. But firstly, I would love to introduce our speakers. Dmitry Tulipov is the assistant professor from the School of International Relations of St. Petersburg State University and an expert of the Russian International Affairs Council. Dmitry has been studying international relations in the Arctic region for almost 10 years now, and his research is focused primarily on the Northern Sea route, Arctic oil and gas policy of different states, and security issues. As an expert of the Russian International Affairs Council, Dmitry is actively involved in analysis and preparation of the new initiatives of the Russian Arctic policy. Thank you very much for joining us on St. Petersburg, Dmitry.
Hello, Katerina. Can I start the presentation?
Well, give me a few minutes, please, because I would love to introduce Ivan as well. Well, then we will hand over to Ivan Matrikin, who is the senior analyst at Statoil. Ivan has been developing new technologies for E&P operations in frontier Arctic offshore basins since 2010. Working for Statoil, he has been involved in greenfield projects in the Barents Sea, offshore Newfoundland, and in the Greenland Sea, mainly focusing on deepwater developments. He's an international recognized researcher in Arctic oil and gas and serves as Arctic and internationally recognized expert at the International Organization for Standardization and Treatment. And she's developing a new generation of operations in the Arctic. Thank you very much for being here.
Thank you.
Okay, that's great that you're here with us. So Ivan will speak about software innovation for exploration and production operations in the Arctic offshore. Well, dear colleagues, I would also love to mention that we will have two polls during this webinar, so we will be able to take into account our audience's opinion during the discussion. You should be able to see the questions on the screen during the webinar and vote, so please take an active part. Also, please at any time. Well, starting with the overview of the Yamal oil and gas investment project, I would like to mention that about 85% of natural gas production in Russia is carried out in the Yamal region. Approximately 70% of total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of the total Russian oil reserves and about 20% in the area. Well, 40% of Dear colleagues, I'm awfully sorry for the technical problems that we have to solve at the moment. Uh, so once again, speaking about the Yamal LNG project, I would like to mention that more than 200 wells will be drilled for the project as 3 liquefaction trains are built, each of which offers an annual capacity of 5.5 million metric tons. Definitely, to ensure its stability, the plant will be supported by tens of thousands of pounds driven some 20 meters into the permafrost. To facilitate the transport of equipment and staff, the port of Sabetha and the airport were built and are now operational. According to current plans, over the next 3 years, the port of Sabetha will take delivery of 150 modules, representing more than 4,100 metric tons, transported from Asia by some 20 vessels. The port will also serve to export the LNG. The second project which I would like to highlight is Gazprom Neft Novi Port. Novoportovsk is one of the largest in the Yamal Peninsula district. Capable reserves of more than 200 million tons of oil and condensate, with over 320 billion cubic meters of gas. Work on the infrastructure needed for full-scale operations is still ongoing, and at the moment oil is being shipped through the transfer complex at Cape Cabernet, which has an annual capacity of 8.5 million tons. Field and terminal linked by a 100-meter pipeline. So the third project on our map is Romanet pipeline and railway line. The next generation of a gas transportation system, which is constructed to transport natural gas. While the implementation of these projects is one of the priorities of commercial development of Yamal, whose GTS has to become over time one of the key elements of the unified gas supply system, providing transportation of gas in the amount of more than 300 billion cubic meters per year from the peninsula fields. So the fourth project for our discussion is the Novi Oldingoy gas chemical complex. The design capacity of the plants shall be up to 400,000 tons of low-density polyethylene, various grades per year. This production facility will become the largest one in Russia. In addition to oil products, the complex under construction will produce a wide variety fraction. And the last project, but not the least obviously, is Zapatari Sample Pipeline, which is aimed at supplying people from major new fields in the Yamal Peninsula district and northern Krasnodar territory to all refineries in Russia. The oil process, which is processed at the refineries, exported to the Asia Pacific region, and obviously, as you see, these projects are quite lucrative for investors. This is the first poll question, and remind you to vote straight away. So the poll question is on the screen now, and I would love to invite you to vote. So the question is, which of the oil and gas companies operating in the region do you consider to be the most effective in terms of subsoil use? So you have a chance to select one of the following options: Novatek, Gazprom, Gazprom Neft, Lukoil, and Rosneft. So you're all very welcome. And then we'll start our presentations. Okay, so now we are turning back to our presentations, and let me hand over now to our first speaker, Dmitry Tulubov. Dmitry, the floor is all yours now.
Thank you, Katerina. In my short presentation, I would like to focus primarily on strategic, political and economic issues of Yamal LNG project. And I would like to consider this project in context of the Russian Arctic strategy, which started its development since 2008. Please. Actually, I think that this is very important to know the general context, because we can imagine what prospects are before Russia in the offshore energy development in the Arctic region, if we consider Yamal LNG project not as a single project but as a part of a general strategy of Russian Federation in the Arctic. Just a brief introduction. The first version of the Russian Arctic strategy was adopted in September 2008. And that document was not very specific about offshore oil and gas development. So there was, in the document, there was only one provision, general character, which specified necessity to increase oil and gas exploration in the Arctic Ocean, in the Russian part of the Arctic Ocean. But the strategy of the Russian Federation's Arctic zone development, which was adopted on 20th of February 2013, was much more concrete about oil and gas issues. I would spark your attention to section 11 of this document, which has two very important provisions about Arctic oil and gas. The first one, establishment of a reserve fund of deposits in the Russian Arctic, which will have a character of long-term reserve fund. So exact formulation of this provision you can see on this slide. And also the second important provision presumed the necessity of implementation of large-scale infrastructure development projects, presuming the integration of the Russian Arctic zone with already developed Russian regions, and development of Timan-Pechora oil and gas province, as well as hydrocarbons on the Barents, Pechora, Kara Sea, continental shelf, and also on Yamal and Yamal Peninsula. So this was the first time when Yamal Peninsula was mentioned in a mental document describing Russian Arctic strategy. Now, please turn to the third slide. Ekaterina? Yeah, thank you. If we proceed to Yamal Peninsula importance in the Russian Arctic oil and gas strategy, we should take into account that Yamal-Nenets autonomous region in general is a home to 90% of total gas production in Russia, and 7 are located here. Specifically, Yamal Peninsula is a home to 26 already discovered gas and oil and gas condensate deposits. Proven gas reserves at this region amount to almost 10 trillion cubic meters of gas. Recoverable gas condensate reserves are estimated at the level of 250 million tons. And of course, Yamal LNG project serves as a sort of pioneering project Yamal Peninsula. And if we proceed to the fourth slide, we will see details, general details of Yamal LNG project, and I suppose that you already know this information, so I will just tell it briefly. So Yamal LNG project has 16.5 million tons production capacity. As Ekaterina already told, 200 wells should be drilled in order to develop Южно-Тамбейская gas condensate deposit. LNG ice-class carriers should bring gas condensate from Yamal to consuming markets. Now, please turn to the next slide. And of course, it's very important to assess the importance of Yamal LNG project in general. If we look at the map, we will see that port of Sabetta and Yamal Peninsula in general are very successfully positioned in the Russian Arctic. So you see that Yamal and Sabetta, they are equally distanced from European and from Asian markets. In terms of the Russian Arctic strategy, this favorable geographical location seems to be very important because in the long-term prospect, when a comprehensive development of the Russian Arctic offshore will start, Yamal LNG will serve as a reference point as a sort of support base for future oil and gas exploration, not only in Kara Sea but also in Pechora, Barents Sea. So this is the first major observation. The second observation is that are tested on this project. They are very important in terms of the future Russian oil and gas strategy. My third, and I suppose the last observation about this project is that still Yamal LNG is the example of onshore, not offshore energy project. So it is the sign that currently Russia is not ready, is not sure oil and gas development in the Arctic. So I suppose that all of you remember the example and the case of Stockman, which was a very promising project, but still it failed due to a number of reasons, foreign economic, but still the majority of experts share this view that Arctic offshore energy projects are very, very complicated, and still much preparatory work should be done in order to develop these projects in the best possible way. So Yamal LNG should be a sort of pioneering project, will be the start of a big story of oil and gas exploration and development in the whole Arctic. So thank you for your attention, and that's all what I wanted to say. And I pass the place to Ekaterina.
Thank you very much, Dmitry. That was a great presentation. So a question for you. Do you consider to be Yamal LNG projects as the one which has the critical strategic importance for the place of Russia in the overall energy balance?
Yes, I think that and economic importance of this project is overwhelming because this is the first major project in the Russian Arctic which has such strong ambitions in foreign markets, and many countries show their interest to this project, not only in Asia like Japan or China, but also France is also an active stakeholder in this project. So I think this Yamal LNG initiative is a first major step, so to say, in the implementation of mention of the Russian Arctic strategy.
Yeah, I think that's a very big question, and thank you very much once again for your presentation and for your opinion. So now I would love to get back to our poll question, which I have announced at the very beginning. You have a chance to see the results on your screens now, and we've asked our audience to choose the oil and gas company which is operating in the region. So obviously the leader of our voting process is Novatek company, which has got 43% of the overall amount of votes. So the second place is occupied by Gazprom. As you see, the percentage difference is not that significant, but still. The third place is given to Gazprom Neft. Of 10% of the votes is given to Lukoil and only 7% to Rosneft. I think the results are quite interesting. Dmitry, what do you think about the distribution of answers? Do you agree with this scheme? Because it's pretty much supporting what you have mentioned according to the Yamal LNG project.
Mm-hmm. Well, usually all polls have some reasonable degree of prejudice, but I think that I will agree with the following idea, that Novatek has a pioneering experience, so it's very consistent to give the first place in this poll to Novatek. Also, I would like to draw a parallel line between Yamal LNG initiative and well-known Snow White project in Norway, because both projects are pioneering. Of course, Snow White is the oldest one, but for Russia, this is the Yamal LNG is the first initiative when we try to build a comprehensive LNG production and export infrastructure in such a difficult region as the Arctic. So in my view, I would I would give the second place to Lukoil, maybe, and the third one to Gazprom. So if I had an opportunity.
Okay, yeah, that's a very fresh approach. Thank you very much once again for your comments. I think that might be a topic for a separate discussion, but now I would love to introduce our second poll question, and we'll give you a couple of minutes for voting. So the second poll question is the following. In your viewpoint, what is the critical oil price for the Arctic projects to reach the break-even point? There are three options, and we've indicated the slots for the oil price per barrel. The first one is from 40 to 55 US dollars, the second one is from 55 to 70, and the last slot is from 70 to 85 US dollars per barrel. Dear colleagues, you can vote now, and after Ivan's presentation, we'll get back to the final results. Okay, so our next keynote speaker is Ivan Mitrikin, senior analyst from Statoil, and he'll give us an update about technological solutions for exploration and production operations in the Arctic offshore, and he will share the experience of Statoil in terms of Arctic project development. I think we're done with voting, right? So, Ivan, the floor is all yours now, and you're very welcome to start your presentation.
Thank you very much, Katerina. So I'd like to start my presentation with a few key figures about Statoil. We are currently the leading oil and gas operator on the Norwegian continental shelf, and we are the second biggest gas supplier to Europe. Last year we were producing roughly 2 million barrels of oil equivalent per day, and approximately 1/3 of that production was being performed outside of Norway. This indicates that although we aim to deepen and prolong our core position on the Norwegian continental shelf, we are also consistently growing our international resource base, and we conduct operations in a stable and profitable way all around the globe. This includes our acreage in the Arctic, where we have licenses in a range of frontier areas. For instance, we are the most severe oil and gas province on the planet due to continuous transport of multi-year ice through the Fram Strait and drifting icebergs. Furthermore, we operate offshore Russia in the Sea of Okhotsk, where the ice conditions are somewhat milder, comprising primarily first-year ice and no icebergs. And finally, we have acreage in the deep water regions of the so-called workable Arctic, namely in the Barents Sea and offshore Newfoundland. Actually, at the end of last year, we secured access to new major acreage in the Flemish Pass Basin, offshore Newfoundland. Those new licenses total approximately 15,000 square meters in proximity to our previous Bay du Nord, Mizzen, and Harpoon discoveries shown here on this slide. This deep water region is very challenging due to the threats from massive icebergs and potential sea ice encroachments. This slide here shows some of the threats we are facing in this region. Basically, we operate an entire fleet of iceberg management vessels that routinely tow away hazardous icebergs from the vicinity of our installations in this region. Nevertheless, our platforms obviously have sufficient hull strength to withstand accidental ice impacts, which results in a capex footprint, of course. Additionally, we are in need of solid tools and technologies for estimating operational expenditures for ice management support operations, as well as for estimating downtime of our production in case of disconnection events. And this leads us to several ICE information and requirements that are shown here. We need to be able to robustly identify when ice can be present in an area of interest, its duration, amount, and type. This information gives input to the analysis of infrastructure accessibility, logistical requirements, and facility design, which are fundamentally driving our decision-making process, which is based on our need to ensure safety of operations, zero harm to the environment, and optimized CAPEX and OPEX. So we have developed a technological platform for addressing these challenges, which I'd like to share with you here. We start our ice management process with observations, and these observations include satellite, aerial, and vessel-based records. Compile into ice surveillance reports, which are given to the orientational experts in our central control point, who integrate them and forecast the operational situation on site. Then this information flows to the decision makers who perform the threat assessment and surveillance assessment. They may find that we need more information or that we need to deploy our fleet of vessels to manage the threat. After that, the decision makers issue ice management commands or request for more surveillance to the actors on the spot who either manage the ice or increase the surveillance efforts. Finally, the surveillance plan is updated, and this closes the so-called OODA loop, which is the decision cycle to observe, orient, decide, and act. It was initially developed and from the U.S. Air Force, Colonel John Boyd, who applied it to combat operations process, often at a strategic level in military operations. And here is an example of how it looks like. On the left-hand side, you can see the path of an aircraft surveilling the region north of Norway, south of Svalbard, when we were performing exploration operations in the vicinity of Apollo and Atlantis and Mercury wells. In the middle is an ice chart which tells us where we can expect sea ice encroachment, and to the right are actual satellite images of our drilling configuration here on site, including the actual drilling rig itself, in this case West Hercules. So if you look at this problem at a higher level, we can imagine it to be the problem of the so-called Internet of Things. On the left-hand section column, you see the platforms and sensors that are being used in this decision-making process. We have the satellites, synthetic aperture radar, optical and infrared. We have aircrafts and remotely piloted aircraft systems, which have on board such sensors as synthetic aperture radars, conventional radars, optical and infrared, and also human observations through remote camera control. On the vessels, we also have radars, optical, infrared, and human observations. We deploy beacons with GPS trackers on ice floes and icebergs. We use AUVs with sniffers, sonars, and optical sensors. This raw information is flowing into the sensor synergy block that integrates it and produces an information layer that is integrated with the meta-ocean data, winds, wave, magnetic identification system for our vessel fleet. That goes into modeling and forecasting loop, which gives feedback to the deployment of an optimal sensor suite and eventually closes the loop to the detection platforms we are using. The final outcome of this loop is the surveillance philosophy and the display that is provided to the decision maker in support of his critical operational decisions. So in totality, this can be summarized as a combination of synergies between optimal sensor suite, integrated information management, and improved models and forecasting. When it comes to improved models and forecasting, I would like to mention one example of a numerical tool we are using, which is called the simulation of interaction between broken ice and structures. This model has been developed by us in Statoil for our internal use, and it simulates ice forces and ice actions on floating structures and vessels in the Arctic. The vessel here is modeled with high fidelity using a detailed mesh representation. We have a description of the propulsion system. It can be nozzled, it can be rudders, it can be azimuth or azimuth thrusters. We have mooring system representation. It can be turret mooring, spread mooring, or other types of mooring systems. And we simulate precise nonlinear hydrostatics, wind and current loads on the vessel, mooring and propulsion system loads, and ice loads. When it comes to the actual ice loads, each ice piece is simulated with high fidelity using its detailed physical and mechanical properties, thickness, density, flexural and compressive strength, Young's modulus, Poisson ratio, fracture toughness, etc. Forces basically lead to a precise description of how the vessel would behave under the influence of the ice environments. Pressure, friction, and failure of the ice, crushing, rufting, flexural bending, and splitting. And this system allows us to perform probabilistic analysis and exposure considerations depending on the type of the ice that is encroaching our operational site. And if we are using our cloud computing GPU accelerated simulation technology, we can in real time play with many different operational scenarios and then take decisions based on the level of threat. In this case, it can be, for instance, the force in the mooring lines acting on the vessel. This concludes the ice-related part, and I would like to wrap up with a video about our subsea development. The latest one is called Next is our new subsea innovation, which is intended to become the standard for next generation subsea solutions. The objective of this technology is to increase efficiency and reduce costs of subsea installations and developments in the Arctic. It is basically produced in much shorter time and with potential for local production, for local content. It moves more activity from the rigs to the supply vessels, and essentially it is built around the well-known suction anchor technology. In this case, steel suction anchors are the foundation of the solution, supplemented by a skirt and a cap in glass fiber. Meters for a cheap and with this, we're basically one step closer to a plug-and-play solution on the seabed. Thank you. That's all I have.
And obviously, the presentation was quite interactive, and the content was great. So questions from our colleagues who are attending the webinar. And I would love to ask you if you will be able to provide more details for ice management vessels. Basically, our colleagues would love to know if there's a specially designed fleet, and it would be great if you can just provide us with a source of information where we could get a more detailed vessel description?
Yes, for more detailed information about the actual vessels used for ice management, I encourage our colleagues to take contact with our there is a section that devoted to operations offshore Newfoundland that gives an overview of our activities, and if further information is required, I'm open to answer dedicated questions. You can get my contact information from the organizers of this webinar.
Okay, thank you very much for the detailed answer. And we've got one more question for you, Ivan. You spoke about the huge volumes of gas production. So our colleagues would love to know any particular details about the new pipeline to the south of Europe. Can you please highlight that aspect as well?
Pipeline to the south of Europe from where?
Unfortunately, we don't really have such a clarification, but if you are aware of the ongoing process at Statoil.
Well, I don't really have any information about pipelines to the south of Europe, so unfortunately I'm not in a position to answer this one.
Okay, that's additional incentive for all our attendees to go and check the Statoil website at least. Thank you very much. So I think we're turning to our second poll question, and I would love to announce the results. So please have a look at your screens, and then we were asking, from your viewpoint, what is the critical oil price for the Arctic projects to reach the break-even point? I must admit that the results are distributed quite evenly, and there is no dramatic difference between the groups of answers. Ivan, would you be so kind to comment on the results of this question as well?
Yes.
Do you personally share the opinion in regards to the final results of this poll question?
Well, I think the results very much reflect the fact that the developments in the Arctic are very diverse, and different projects, depending on their geographical location and the fiscal climate, have very different break-even points. I think the results here indicate that we have a very professional audience who have an overview of the different projects, and they have different information on the actual break-even points. And I think the results here are very, very correct. It is possible to develop oil fields in the Arctic with 40 to 55 of the participants answered. But some projects require a higher price, obviously.
Okay, thank you very much for your comments, Ivan. And in fact, we still do have time, and we do have quite a few questions. If you don't mind, I'll switch to the next one. So our colleagues are asking, what will be the most probable solution for maintaining the position of drilling platforms for, let's say, anchored solutions, dynamic positioning? Can you please give us some comments in regards to that question?
Yes, certainly. With regards to station keeping, I guess the question here comes to Arctic operations in presence of sea ice, because if it's operation in open water, then conventional very well. The difference in the Arctic is that when the sea ice encroaches in an operational site, the forces induced on the platform are substantially different from those induced by waves, winds, and currents. So we need a specially designed system sometimes. Basically, in deep waters above 2,000 meters, mooring solutions are to a large extent uneconomical due to the installation costs. So we rely on DP. And DP is generally the preferred method for exploration drilling. However, for production, mooring systems are much more widespread and much more preferable, especially turret moored solutions for submersibles. Of course, can also be used, but if sea ice encroaches, then semi-submersibles have severe challenges with station keeping due to their waterline configuration. So for sites with high probability of sea ice encroachment, the answer would be a ship-shaped hull with turret moored system, not centered, probably closer to the bow, so that it has passive vaning capability, and if possible also a DP system for thruster-assisted heading control. That would be the most robust answer in my opinion.
Okay, thank you very much, Yamal. That was a really detailed answer, and I would love to thank our speakers, Dmitry and Ivan, for the engaging presentations, and definitely a separate thank you, a separate big thank you goes to our active audience for their participation and questions. And the last thing is that I would love to invite you all to continue our discussion on the 8th and 9th of June in Salihard this year at the 5th Annual Yamal Oil and Gas Forum, which traditionally brings together the top management of Russian and foreign oil and gas companies, independent oil and gas producers, processing and engineering firms, market operators, representatives of all the supervisory authorities in the field of natural resources and environmental protection. So, dear colleagues, once again, thank you very much for your participation, and I'm looking forward to seeing you in June this year.
Thank you for an interesting discussion.
Thank you very much, dear colleagues. Hope to see you soon.